Thought we'd take a quick look at PET scanners, and this has got nothing to do with taking a really fat chinchilla and scanning it. Got nothing to do with that at all. PET stands for positron emission tomography. So we're getting a picture, we can tell it because it's a graph, there's a picture in there somehow, and there's been some positrons emitted. So a quick recap on when positrons are emitted. Occasionally a neutron might decay, and a neutron has got a mass of 1, but it's got no charge, and it might decay into a proton which has got a mass of 1 and the positive +1 charge, P. And as well as that, we get an electron emitted from the nucleus of an unstable atom, in which this neutron is decaying. An electron has got an insignificant mass and a charge of -1. These mass numbers, by the way, balance, so 1 plus 0 is 1, and here the charge also balances, +1 minus 1 is 0. And that is commonly known as beta minus decay, commonly found in unstable nuclei. Alternatively, if an unstable atom, the nucleus of an unstable atom, has got too many protons, or should I say not enough neutrons, then that proton, a proton inside the nucleus, may well decay into a neutron, and as it does so, to balance the mass and the charge, it might need to emit this particle, which has got no mass or insignificant mass, but it's got a positive charge. Strange. We call that beta plus decay. Now, beta particles are actually made of electrons, but this is a positron, and it's actually antimatter. And antimatter exists in the universe, but not in our vicinity, because as soon as antimatter meets matter, they annihilate each other and turn to pure energy. So should that positron emitted from the nucleus of an unstable atom, it will be attracted to any nearby electron, because they've got opposite charge. They'll be attracted to each other, and like Romeo and Juliet, they will destroy each other with their attraction. The electron meets the positron, and they will actually make 2 gamma waves. This principle was first outlined by Einstein with his equation E equals mc squared. Energy is equivalent to mass multiplied by a factor that is the speed of light squared. A very large number. In fact, it's number 9 with 16 zeros after it, meters per second. So what we're saying here is that mass is actually a very condensed form of energy, but when these two masses come together, matter and antimatter, they can convert that pure energy into a gamma wave, which is just a pure wave of energy, an electromagnetic wave of energy. So effectively, these two particles disintegrate, annihilate, turn into pure energy. What has this got to do with scanning? What we could do is we could get someone who isn't very well, and we could inject them with something that is radioactive. Now, before you say that's not very nice, it's actually quite a nice thing to do if it helps us work out why they aren't very well. And let's get some toes on there, knobbly knees. And what we can do is inject people to look inside their body. We can inject them with a radioactive isotope. And this radioactive isotope, let's draw a little crystal here, would be attached to a glucose molecule, C6H12O6. And glucose is used by the cells in our body for respiration. But let's say, for instance, this poor person has got a tumorous growth in their body, and many forms of tumours or cancers or whatever will take in an awful lot of glucose because they are making new cells and growing very quickly. When we inject this person with a radioactive isotope, then this radioactive isotope here, which is attached to the glucose molecule, will get absorbed by the tumour and other cells in the body. So in fact the radioactive trace will get absorbed by all body cells, but there will be a concentration of them around the tumour. Now these, if we take a positron emitting radioactive isotope, so this is giving out positrons, beta plus particles, then these positrons, when they meet an electron, will give out gamma waves. So we can inject them inside the body. They will actually then give out gamma waves, and these gamma waves will be concentrated in the region around this tumor. We can then see whether this person has got some growths that shouldn't be there, and we can particularly do this inside the brain, for instance. So this is a non-invasive process, and no danger of infection or damaging healthy tissue too much. These gamma waves come out of the body. They don't do too much damage on their way out of the body, and within a few hours that person would be okay to hugging chinchillas. But for several hours that person will have to stay away from chinchillas, or indeed small children, or indeed pregnant women, and the reason for that is because they will still be giving off gamma waves for several hours, but after a very short time they will be fine. Hopefully we'll know a lot more about whether or not they've got some nasty growths inside of them because of the positrons that were emitted and the picture that was made. When positrons were emitted by a positron emitter inside their body that was attached to a glucose molecule that was absorbed by a tumour, and the gamma rays that came out could be detected by computers to create a 3D image of the insides of the person's body. Thank you.